Okay, so here we are with lesson number 7. We're going to look at kinetic energy today, calculating kinetic energy. So a quick recap from last lesson. Read the questions, look at the hint, and have a go. Okay, so if you've had time to work out those answers then, recall question the first one. What is the equation for gravitational potential energy? You do need to learn this. Don't worry if you had to look back in your book for the moment, but remember we need to work towards learning these equations. So gravitational potential energy is mg/h, mass times gravitational field strength times height. This question is a nice easy one, so I've given it an F for the moment just because there's nothing else to work out, just substituting the numbers you're given in the question into the equation. So our M in this equation is Katie's got a mass of 50 kilograms, so that's there. Gravitational field strength was given in the question, that's there, so that's the next bit. And the shard, top of the shard, 310 meters tall, so 50 times 10 times 310, 155,000 joules. Don't forget to write out your substitution, do the working on your calculator, write your answer and with the units. And the only reason I've graded this one higher for the moment, by the end of this course everybody needs to be doing all of these questions, is just because we were given the mass in grams instead. Did you spot that? So the hint was to to convert units first of all. So that's the first thing you need to do, is turn your 140,000 grams into kilograms, and you do that by dividing by 1,000. Okay? So our EP then is 140 times 10 times 310, gives us 434,000 joules. If you don't do the first bit, but you show the workings out of everything else, you can score the rest of the points. That's why it's so important to show the workings out. All right then, so we're going to start off by looking at a roller coaster, and this is because gravitational potential energy and kinetic energy, we often swap one for the other when we've got a moving object. Okay, let's start by looking at the gravitational potential energy for our roller coaster. So you have to design, this sheet will have been given out with the lesson, so you have to design a roller coaster that passes through these 3 points, A, B and C. You can do a loop-the-loop if you want to, it doesn't matter on your paper, just draw it, but it must pass through points A, B and C. And then what I need you to do is read the information carefully given there, and go back and calculate the EP at the start and at points A, B and C. So pause the video while you go and do that. Okay, so at the start then, our gravitational potential energy is our 5,000 kilograms times 10 newtons per kilogram times 100, because it was 100 meters tall at the start, gives us 5 million joules. At point A, it's a bit lower, so our gravitational potential energy is a bit less. Okay, it was only 40 meters tall, so that's what you should have for A. Pause the video if you need to get the answers down, self-assess your answers. And at point B, slightly more, but less than the start, because it was only 70 meters at B. Okay, and we're taking that off of the axis over here. Okay, and at C, you should have spotted that it's the same height as A, so therefore gravitational potential energy will be exactly the same as it was at A. Okay, excellent. So this lesson then, if we can state the factors that affect the kinetic energy store, which we haven't looked at yet, then that'll be grade 4 and 5. Calculating, okay, would be level 6, and if we can rearrange the kinetic energy equation, then we're looking at a level 7 and above. Okay, so the next thing I'd like you to do is pause this video, go back to the PowerPoint version so that you can pick up this link and then watch this kinetic energy video, which is only 3 minutes 54 long. It compares the kinetic energy of 2 objects, and it shows you how to calculate kinetic energy too. So by the end you should be able to answer this question. So pause this video, go off and find the link and watch that one. Okay then, so moving objects have stores of kinetic energy, okay, and gravitational potential energy is the energy stored in an object because of the height which it is lifted up to. So that's what we looked at last lesson. So let's look now at what the equation for kinetic energy involves. What 2 things are involved in kinetic energy? So you should have got that from the video. This is a recall equation. It looks slightly complicated because we've got a half here and we've got a velocity squared there. Okay, so the 2 things that our kinetic energy depends on are the mass of an object and its velocity. Now, some people say it's speed at this point. Velocity is speed in a given direction, which we'll come on to a bit later when we look at unit P5. So let's not worry about that for the moment. Let's just say for the moment we can think of velocity as being like the speed of an object. Really, it's the speed in a given direction. Okay? All right, so we've got kinetic energy equals half times mass times velocity squared. That means velocity times velocity. That's what squared means, doesn't it? Okay, so let's look at how this would look in an example, and I suggest that you pause the video and you copy it down carefully. So a runner of mass 75 kilograms runs at 10 meters per second. That's the speed they are running at, the velocity they're running at in a given direction. So their kinetic energy, and can you see the symbol, similar to last time, a big E and this time a small k standing for kinetic, is half times mass times velocity squared. Notice when you write the shorthand that we often omit, we leave out the multiplication sign. Okay, so we put in a half. Now on a calculator that's 0.5. Okay, so don't get confused by that. Our masses are 75. Okay, so that's next, and our velocity squared is 10 squared, which means 10 times 10, 10 by it multiplied by itself. Okay, and gives us the answer 3,750. Copy the layout, it's really important. And then we're going to practice the question. Okay, so here we've got a car with a mass of 1,500 kilograms travelling at a speed of 20 meters per second. Okay, so velocity 20 meters per second in a given direction. So the kinetic energy of the car then is half times mass times velocity squared. So half is 0.5 on the calculator, times 1,500 times, and you can either put into your calculator 20 squared or 20 times 20 if you're happy with that. And that gives us 300,000 joules. Excellent. Okay, if you want to work out something else, this is asking you to calculate velocity. So you have to substitute the numbers in that you've got for something, for what you have got into the equation to work out something that you haven't got. Okay, and here I've cheated a little bit by rearranging the equation for you. Okay, so here I've rearranged the equation and I said velocity equals, this sign means the square root of twice EK divided by the mass. And we've substituted the numbers there into here, and that will give you 50 meters per second. So what I need you to do from this equation is you could write down what the velocity means, or let's have a look at it on the following equation, because this is a slightly harder equation to rearrange. Okay, so here's the original equation, half times mv squared. Here it is rearranged to calculate velocity. It's the square root of twice the EK divided by the m. And here we've got mass on its own, which would be twice EK divided by the velocity squared. So there's two ways that you can do this. You can either look at learning these two, okay, or you can look at how you rearrange that equation, like I've shown you in the separate rearranging equation formula video. Okay, all right then. So we need to practice using these two recall questions, recall equations, and here they both are. We've got gravitational potential energy, and we've got the kinetic energy equation. Now this one up here, I didn't spot this earlier, I have to go back and change this. We've been using, this uses GPE, and it should have been changed to read EP. Okay, so I'll go and change that on the PowerPoint that comes with this video. All right, so have a go at these two questions here, and then to secure your understanding there are some worksheet questions for you to try on. Okay, so pause the video while you have a go at these, and then we'll look at the answers. Okay, so you'll spotted that I've changed to the right symbols here. Okay, EP is your preferred symbol by the exam board. Okay, so try to use that one for gravitational potential energy. So here are the answers to those two questions. We've got a 5 kilogram bowling ball lifted to a height of 2 meters. So 5 times 10, because 10 is the gravity, 10 newtons per kilogram for the gravitational field strength there, times 2 gives us 100 joules. And then using the kinetic energy equation, half times 70 times 3 squared. Don't forget the squared. Okay, excellent. Now then, you can now go back to the engager sheet that you started last lesson, because you had calculated gravitational potential energy for the helicopter, the man at the top of the ladder, and the child. So now what you can do is you can go and calculate the kinetic energy for the car, the ball, and the bullet. So off you go, have a go at that. Okay, so let's have a look at our answers then. So for the car, 0.5 times 800 times 6 squared, 14,400 joules. This is where we get most of the mistakes made, because people forget to square the velocity there. Okay, all right, and then we've got the ball, football, 1,260, and the bullet. So interestingly enough, more kinetic energy from stored in the bullet there, because it's going at such a fast speed, even though it is very light. Okay, so here then, what factors does EK depend on? It depends on the mass in kilograms and the velocity in meters per second. So which one had the most EK? That was our bullet. Okay, our travelling bullet. Excellent. Now, what we need to do now is to practice our EP and our EK before we move on to linking them together. So for this, there are some worksheets attached, okay, a recall equation sheet for you to practice with the answers supplied, and then some foundation, and also some foundation and higher questions are provided too. Okay, so have a go at trying those. You'll find the mark schemes are attached to them, or linked, so that you can mark those. Now, we're ready to link this, so I'm going to put this on the end of this video here, and then I think I'm going to make another one to go through it in more detail. But if we're talking about a roller coaster or a yo-yo, we've got changes in energy stores going on. So remember from what we did on an earlier lesson that energy is converted from one energy store to another. That would be a better way of saying it. One energy store to another. So as the roller coaster moves from the top of the loop, where it's got its maximum gravitational potential energy, we are transferring energy into its store of kinetic energy, which is getting bigger and bigger as the roller coaster speeds up. Okay, but in a perfect world, we wouldn't lose any of that energy, we wouldn't dissipate any of that energy to the surroundings. However, we in the real world will have frictional losses. Okay, so the roller coaster would arrive at the bottom of the track, having lost some of its energy. But in the perfect world, where we didn't lose any energy, what we would say was that it would arrive at the bottom of the track with the same amount of energy in its kinetic energy store that it had in its gravitational potential energy store at the top here. So I'll go over this again at the start of the next video. Meanwhile, get on with your practicing. Okay? All right, see you next time.